A great privilege today to introduce Professor Sarah Coakley, who is the Norris Hulse Professor of Divinity here in the University of Cambridge, and she's a Fellow of Murray Evans College. She originally studied at Cambridge and at Harvard, and she has had a number of university positions following that. First of all, a lectureship in the Religious Studies Department at Lancaster University, then University Lecturer in Theology at Oxford, and Tutorial Fellow of Oriel College. She was made a tenured Professor of Christian Theology at Harvard, and then had the Mallinckrodt Professorship, prestigious chair at Harvard University, before being attracted back, I'm glad to say, to her roots here in Cambridge with the Norris Hulse Chair in 2007. Now, Sarah's a philosophical and systematic theologian with a lot of publications to her name, a great book on the theologian Ernst Troeltsch, for example. But while at Harvard, she developed an interest in the science-religion dialogue and worked collaboratively with a couple of eminent scientists, and particularly in the latter stages with Martin Novak, the evolutionary biologist, mathematical biologist. And her work with him has led to the Gifford Lectures, which she recently gave, and to the lecture we're about to hear today. And you have a handout, and all the lectures in due course, I don't know if there's a link on the handout, and all the lectures in due course will be published. And the title of that is going to be the Evolution, Games and God, the Principle of Cooperation, co-edited with Sarah with Martin Novak. So it's a great pleasure to have you here to talk to us.
Thank you very much, Rodney. Rodney and I go back a very long way. Rodney was a friend of my husband at Trinity College, Cambridge, in the 70s. Everything goes round in cycles. Thank you. It's lovely to be with you. And thanks for the kind introduction. And particular thanks, actually, to Zoe and Gail for setting everything up so nicely. Well, in this short lunchtime presentation, I've been asked to do the impossible, which is to give an overview of the recent Gifford Lectures, which, by the way, are separate from the book just mentioned by Rodney, which is, the book just mentioned by Rodney is a co-edited collection by Martin Novak and me, which is coming out in the spring from Harvard University Press. And then the Gifford Lectures themselves are called Sacrifice Regained, Evolution, Cooperation, and God. And they're available online, so they're actually published, and I've given you the web link, and all the text and the handouts, and also, I regret to say, some not very flattering videos of me giving them are there. So what I want to do today, in attempting the impossible, is to take actually half an hour revisiting the science that set me off in this direction. And here I've been heavily reliant, of course, on my collaboration with Martin Novak, who is perhaps most famous now for his mathematical account of the evolutionary phenomenon of cooperation and its significance, how to decide on that significance for the whole scope of evolution. Famously, he says that, in one of his articles, that the principle of cooperation is of equal significance alongside mutation and selection in the whole spectrum of evolution. We'll see whether you agree with that later. But I think I've not left him without a few dents in his own edifice, and so by having the extraordinary honour of, courtesy of the Templeton Foundation, spending 3 years sitting in his laboratory, talking with his postdocs, watching how they work, watching how they push the envelope of science, how they speak to one another, how they use narrative discussions to sort of get the juices flowing from new mathematical experiments. It's a very fascinating undertaking. But I was there, of course, asking philosophical questions, asking semantic questions, pressing them on their definitions, pressing them on the metaphysical assumptions that they might be making without being aware of it. And so this is where the collaboration, I think, was mutually fruitful. So what I'm going to do today is to carve quite a big slice out of my second Gifford lecture, where I actually look at what the last decades have achieved in evolutionary science in considering the significance of cooperation across the spectrum. And then at the end, in the time available, I'm going to sit down and do some hand waving, which I'm not very proud of as a philosopher, but I want to indicate briefly what I have made of these phenomena after 5 years of thinking about them, what meaning I attribute to them. And in particular, I'm going to try and avoid two pitfalls which I think science and religion discussions can often fall into. And I call those pitfalls naive correlationism on the one hand, and the fact-value disjunction on the other. Naive correlationism tends to say, gosh, that's some really interesting science going on there, and it reminds me of the doctrine of the Trinity. I think I'll have them both, which are not going to persuade any operating scientists that that would be anything other than a hypothesis that they can do without. And the fact-value disjunction, which has a sort of Kantian tradition to it, is equally problematic in my view, and often goes along with naive correlationism. And there, as the chief rabbi and the Archbishop of Canterbury recently said, when the latest argument about the Big Bang came up, well, science deals with the facts, and we theologians deal with the interpretations. Now that won't do either, because science is absolutely riddled with interpretation. And the question is, are its own interpretations actually mandated by its mathematical and empirical activities? So I'm going to set off to give you a flavour of what I've learned from Martin Novak. And then at the end I'm going to sit down and talk to you about what I think the ethical and theological consequences might be for this, avoiding those two pitfalls. First things first. When I first met Martin, I noticed that he and his team were in a kind of semantic quagmire. They were using the term evolution and the term altruism interchangeably, for a start, which is quite common in the literature. And I found that they were also sometimes, in conversation with other biologists, using even those terms quite sloppily. So if I start to talk to you over lunch about cooperation, you may think in ordinary language, careless speech, that this means us working together for some shared goal, collaborating, if you like. And indeed, some empirical biologists do use cooperation in this rather loose sense, in sort of in the sense of mutualism, where there is benefit to both sides. So after I joined Novak's team, I wanted to find out how precise their own definition was of cooperation when they published articles on this. Of course, the underlying answer is that they have a very precise definition mathematically, but then when they talk about it in language, it doesn't always keep so precise. So you might want to look at the two articles that I've mentioned on the handout, from an article, a famous article by Novak in 2006, and a more recent one by 2012. They can both be easily downloaded, in which they slide around without demur between mathematical accounts of cooperation in slime molds and the same as applied to human sacrificial acts of compassion. That's the Good Samaritan. So one of the first theoretic points I raised with Novak then was this apparently false elision. There's a danger, in fact it's a double danger, that goes in both directions. Such talk about cooperation can both move from the pre-human to the human, as if there was no change of gear, and thus suggest some kind of determinism or reductionism, not taking account of the human differential. Or it can go the other way, which it often does, and I shall slide into this a bit in my exposition. It will talk about slime molds as if they had intentionality and were making choices. All right. So this is a sort of double government health warning. We must not make these same mistakes in what we're about to do together. And the excellent article by Benjamin Carr, Peter Godfrey-Smith and Marcus Feldman on your handout will give you a cold bath on this if you want one. So in the end, before we wrote a book together, which is coming out next spring, Novak and I agreed that we were going to come up with some definitions that we would stand by, at least in our team. And so we define cooperation in the following way: a form of working together in an evolutionary population in which one individual in the population pays a cost in terms of fitness, whether genetic or cultural, and another gains a benefit. Whereas, in contrast, altruism, as a subset of cooperation, should be reserved, in our view, for conditions of additional affective intentionality. Altruism is a form of costly cooperation in which an individual is motivated by goodwill or love for another or others. You see the difference between those two? Now, it's very unlikely that this distinction between cooperation and altruism, as now happily rehearsed at the Harvard Program for Evolutionary Dynamics, will have effect of imposing any new consistency on biologists' rather untidy semantic usage here. And unfortunately, this is an area of science where there's a fantastic amount of infighting, often resulting from people passing in the night about their initial semantic definitions. But one of the most other, I think, sensitive books along these lines is Elliot Sober's and David Stone Wilson's book, Unto Others. And they talk of evolutionary and psychological altruism, which is roughly similar to our cooperation and altruism. So just to help you there. So, the most important point to cling to as we traverse this semantic minefield is that our own initial generic definition of cooperation, a form of working together in an evolutionary population in which one pays a cost in terms of fitness and another gains a benefit, which admittedly is still a little fuzzy at its edges philosophically, conceptually. What is the cost, you may ask? What is the benefit? When does it happen? Can be rendered entirely precise when expressed mathematically. And we'll be coming to that in a moment. All right, that's the first point that I wanted to get across most strongly. Now, I'm going to suggest in what follows that, if you like, you can call cooperation blip, and you can call altruism block. It doesn't matter what you call them, as long as you're clear about the distinction. In the latter, there's a supervenience of human intentionality, which makes a great deal of difference to the phenomenon. That doesn't mean there isn't some continuity from one to the other. Now, here's my friend and collaborator, Martin Novak, and I'm going to run you through his usual account of how mathematics can help us explain what he calls the dynamism of cooperation in the whole spectrum of evolution. And the first and most important point, and I'm starting with real basics, with apologies to those of you who are extremely eminent scientists, is that, strictly speaking, of course, Darwinian evolutionary theory applies to populations rather than individuals, or rather, it can only throw light on individuals insofar as they inhabit populations and reproduce within them. It is within populations that replications and then mutations occur. It is through mutation that selection then, quote, chooses the fitter model. And this pattern is found right through the evolutionary tree of life, if we may call it this. As mutation and selection over time produce new and more complex branches of life, from the bacterial level through to the archaea and so to the eukaryotes, and so on up to animal and human life. One of the most important things here, really fascinating things, drawn attention to by Maynard Smith and his collaborator Eos Satmari, is that each time a transition is made into a higher form of life, we now understand that there has to be a patch of stable cooperation in order for that breakthrough to occur. This is really interesting because it shows that there is, as it were, a kind of ascending set of transitions in evolutionary life. And cooperation plays a very, very crucial role in those transitions. It makes someone like Michael Polanyi look fashionable again. More of that than not. Okay. Now, the genius of Darwin, of course, was to see that the pattern of replication, mutation, and selection could have explanatory force throughout the full range of evolutionary expression. He had some intuitions in The Descent of Man towards the end of his life about how cooperation, he didn't call it, he called it social selection, might work, which was spot on. But he had absolutely no idea how to explain it, really. But as usual, Darwin was sort of 100 years ahead of most everybody else. Now, in Nowak's words, cooperation, however, is needed for what he calls construction in the genome, in cells, in multicellular organisms, and in animal and human societies. By this he means that mathematical accounts of evolutionary processes can now probe and clarify the way that cooperation alongside mutation and selection is vital for the ongoing productivity of evolutionary change. This probing of structure involves focusing on what Novak and others in this field of game theory call evolutionary dilemmas. Of course, that's to use anthropomorphic language, but just put that in inverted commas. The point is that giving an account of how cooperation fits in evolutionary populations means showing how, against seemingly overwhelming negative odds, that is, in a dilemma where things should have gone the other way, if you don't take into account how cooperation works, cooperative options nonetheless succeed in fitness terms. And note that from here on, where I've borrowed some of Novak's slides for this part of my presentation, Novak opts to use anthropomorphic language, as I've warned you, to discuss these evolutionary options. However, the crucial matter here is that to show that a cooperative choice, that is, one that surrenders fitness in such a way that another gains a benefit, can, paradoxically, be overall beneficial for the flourishing of an evolutionary group. In terms of the classic economic prisoner's dilemma story, which I'm sure most of you know, the story of two prisoners separated from one another in different cells, who can either rat on one another or not. In that condition, it is rational for both prisoners to defect, that is, rat on the other, hoping that the other one won't, because that way the prison sentence for the latter will be lighter or lifted. But if both do this, the outcome is going to be far worse than if they had both cooperated. That is, if they had both stood by their commitment to each other, their alignment with one another, for the sake of a shared mutual goal. So the dilemma here in this story is that if you cooperate and I defect, and I rat on you, I do very nicely indeed. But if we both work that out as the best rational strategy, and we both defect simultaneously, we will both do very badly. So it would be better if actually we both cooperated, which works out to be a strategy that takes us forward together in a way that both of us lose a bit. We would have done better if I defected and you cooperated. But nonetheless, it's much better than if we both defected. Now that's the dilemma. I'm in the cell. You're in the cell. Are you going to rat on me and hope that I don't because I'm such a sucker? You'll do very nicely. Or are you going to say, I think I'd better cooperate because if we both do that, it will be better for us both. That is the sort of classic way of describing in story form the kind of dilemma in which cooperation is balanced against defection. Now, it follows that since, here we are, here what is the dilemma? Two rational players defect and end up with a low payoff. Two irrational players might cooperate, supposedly irrational, and receive a higher payoff. So it follows that defection, ratting in that term, always gives higher payoffs as an initial strategy. If you want to turn this into Dawkinsian language, selfishness pays short term. Okay. But, on the other hand, it actually favours cooperators over defectors long term in terms of overall fitness in certain particular circumstances of dilemma where we can explain how that can be. Now this is what's really fascinating about this whole set of discoveries and developments, because it really shows that the countervailing force of cooperation over against selfishness or defection wins out for a population under certain particular circumstances of dilemma. The question is, which are they? Which are the circumstances in which it actually pays off not to behave in a selfish fashion in terms of fitness? So we need to find those particular circumstances, the kind of leg up that creates the circumstances in which that will work out. And this is where Novak's systematic contribution to the discussion of evolutionary cooperation has, I think, recently been justly to the forefront of attention. He's building here on a long tradition, reaching back into the middle of the 20th century, Haldane, Axelrod, Maynard Smith, Hamilton and Tribbles, amongst others, and then his own Dr. Vater, Carl Sigmund. But in his two recent survey articles from 2006 and 2012 I've already mentioned, he sums these up to give an account of the 5 particular conditions under which cooperation can attain an evolutionarily stable state. And these are the conditions of what are termed kin selection, direct reciprocity, indirect reciprocity, spatial selection, which he'd earlier called network reciprocity, and finally group selection. The last was the one on which Darwin already had some notably remarkable intuitions. I'm going to explain these very briefly. So this is what we're looking at. We're looking at conditions under which, if you were just thinking about mutation and selection, you would think that cooperation really couldn't get an eye in. All right. But if you look at particular dilemmas in which it turns out that cooperation is capable of becoming evolutionarily stable, you'll want to know how that can come about. You'll be looking for the sort of X factor which allows that to occur. And not only allows it to occur, by the way, but if it didn't occur, species would go into decline. That's the other really interesting thing that's been shown. That if you have a species or a subspecies which entirely consists of defectors, there will be an inexorable decline in due course. There has to be this countervailing cooperative factor involved. So very fast here, kin selection. The eccentric communist biologist, I'm sure known to many of you, J.B.S. Haldane, was the first to identify the phenomenon of kin selection first, whereby evolution could be shown to favour cooperation if the donor and the recipient of costly acts were genetic relatives, and so passed on survival, as well as the tendency of mutual protection. I will jump into the river to save 2 brothers or 8 cousins. It was William Hamilton, Bill Hamilton, however, who later attempted to formalise this first cooperative mechanism mathematically, whereby, according to him, the coefficient of relatedness must exceed the cost of cooperation over the benefit of cooperation. We'll come back to this at the end, because this has just become immensely contentious again. And this came to be called Hamilton's rule, a formula which Novak has more recently challenged. So that's the second condition under which we can talk about cooperation becoming evolutionarily stable, or winning out, if you like, was explicated by the even more eccentric, there seems to be a great history of eccentric biologists here who've been interested in this, by social biologist Robert Trivers. He examined the notion of what he called direct reciprocity to show that even unrelated individuals in a population could, in some circumstances, develop and maintain cooperative practices. How? It's a kind of repeated prisoner's dilemma. If one cooperated now, the other might well, in response, do so later by a kind of mimesis. And hence, overall, it might turn out to pay off to cooperate long-term on account of the mutual benefit. So this second game theoretic framework is known as the repeated prisoner's dilemma. Thus, if we look at this putative set of repeated interactions, we can see how cooperation might, in principle, become stable, at least for a while. Robert Axelrod incisively posed the question about the strategies that could produce such results. What is good strategy for playing this game? And Anatole Rappaport clarified how mimetic reactions to defection and cooperation might constitute a series. So you see someone cooperating, you don't do it that time, but the next time you do. And so that changes the interaction. Now the problem here is that this is apparently unstable. Erratic manifestations of defection can then be themselves imitated and cause an all-defection outcome, threatening the stability of cooperative strategies. Novak calls this the problem of tit-for-tat's unforgiving capacity. Notice he's bringing in moral language here. Watch out. But there may also be a solution to this drift towards all defecting. It's what Novak in some of his articles has called generous tit-for-tat. So there can be always defect, tit for tat, and then a pattern may set up whereby there are some entities in the population that don't respond inexorably to a defection with another defection. This allows for the possibility that even if a player meets a defection, she will nevertheless continue to cooperate under certain circumstances in which the overall benefit is greater than the cost. Under these conditions of generosity, which Novak again anthropomorphically calls the evolution of forgiveness, we have a continuing chance for cooperation even when defection in tit for tat appears to threaten it. So generous tit for tat goes, if you cooperate, then I will cooperate. If you defect, then I will cooperate with a certain probability. And that allows for the possibility of cooperation becoming stable. Now, the third rule for the development of cooperation is termed indirect reciprocity and relies heavily on what evolutionary biologists call reputation. The first two rules we've looked at apply anywhere in the evolutionary spectrum. This one only really gets going when you get up into the higher mammals, because it involves knowing that a certain friend or relative of yours has a certain reputation for flipping you or being friendly or whatever. So we can't really see this developing until we get into the higher mammals, and it becomes much more intense in humans because you can use language then to establish gossip about reputation. And it's here that Novak's teachers, Carl Sigmund and Novak himself, have made particular breakthroughs. This rule applies principally, as I said, in the human realm. Here one cooperates with another, one whom one might not meet again, but the behaviour is observed by others and eventually evolutionarily rewarded because of that. Natural selection turns out to favour strategies that base the decision to cooperate on the reputation of the recipient. Once human language is in play, this mechanism is particularly effective. Reputations, of course, spread by gossip. I know that Rodney is a lovely, forgiving person, so I would never do anything nasty to him, etc., etc. So the establishment of cooperative patterns can become more pronounced under these conditions. As our colleague at Harvard, the biologist David Haig, has put it, for direct reciprocity you need a face. For indirect reciprocity you need a name for gossip. Now, a fourth circumstance in which cooperation can win out occurs in what is now called spatial selection, sometimes called network reciprocity, in which defection does not naturally dominate in a well-mixed population because cooperators form clusters which protect and enhance the success of their cooperation. And it turns out that one can graph such clusters of cooperation, and that a surprisingly simple rule determines whether network reciprocity will favour cooperation. The benefit-to-cost ratio in fitness terms must exceed the average number of neighbours per individual in the cluster. Again, humanly, we all know this, don't we? We know that if nice guys get together, they can support one another. Likewise, nasty ones, of course. And fifthly, and lastly, there is the controversial group selection, sometimes called multi-level selection, on which Darwin had his notable intuition. He said at the end of The Descent of Man, there can be no doubt that a tribe including many members who are always ready to give aid to each other and to sacrifice themselves for the common good would be victorious over other tribes. And this would be natural selection. Here, a population is divided from the start into groups, and in some cases groups of cooperators fare better than groups of defectors. The reasons for this continue to be debated mathematically, and much depends on how you model this group selection. However, in a competition between cooperator groups and defector groups, pure cooperator groups can be shown to grow faster than pure defector groups, even though in a standard well-mixed population, defectors will still tend to win out. Now, what conjoins all five of these different evolutionary mechanisms, concludes Novak, is what he calls in rather depressing utilitarian language, a payoff matrix in which cooperation can be shown to be favoured in repeated choices between the two basic strategies of cooperation and defection. And what is particularly fascinating about this discovery, as I mentioned already, is that it explains the paradoxical fact that whereas defectors always win out initially in a well-mixed population in terms of fitness, they do so at the cost of the average declining fitness in the population as a whole if too many of them defect. Cooperation, then, in its various forms, is, you might say, the mysterious key to the regeneration of fitness in evolutionary populations. It may even lead us to say a little hyperbolically, and counterintuitively to be sure, given classic Darwinism, that down the road evolution ultimately favours, I'm going to use a theological language, sacrificial, or what Novak calls forgiving or non-punitive behaviours. So, that's a very, very breezy tour. So let's just review. Let's recapitulate the 5 rules, 5 mechanisms in conditions of evolutionary dilemma for the evolution of cooperation as a stable strategy. Kin selection, that's cooperation with genetic relatives. Direct reciprocity, or tit for tat in various forms. Indirect reciprocity, I help you, someone else helps me, by imitation, but indirectly. Spatial selection, clusters of individual cooperators do well evolutionarily. And group selection, groups of cooperators outcompete other groups. Although it's not impossible that yet further mechanisms for the evolution of cooperation will be discovered, it is already remarkable that so many different conditions of favoured cooperation have been isolated and mathematically explicated. Moreover, Novak's mathematical approach has already proved remarkably fruitful in a wide variety of quite practical applications. I don't know whether you're aware of this. Cancers of various sorts, for instance, are straightforward examples of uncontrolled cellular defection. That is what a cancer is, causing the breakdown of an organism. And this development can be illuminatingly mapped mathematically with predictive force. So I wouldn't be surprised if Novak wins the Nobel Prize ultimately for that. So even in the realm of cultural evolution, quite different of course, the transformation of various verb forms in linguistics over decades and centuries is also analysable in these game theoretical terms, amazingly. However, this whole area of theoretic development, I'm going to spend 2 minutes on this, because if I try and avoid it, some of you will wonder why I'm being so evasive, is not without explosive controversy. And we now come to a final postscript about kin selection, to go back to the first rule of cooperation. Does any of you know about this? Have you been following this in the pages of Nature? Right. For here, Novak and 2 collaborators, E.O. Wilson, whom you know of old from sociobiology and ants, and Novak's brilliant postdoctoral student, Corina Tarnita, have recently caused a huge kerfuffle by publishing this article in Nature 2010, The Evolution of Eusociality, which directly challenges the mathematical efficacy of Hamilton's rule in explaining inclusive fitness, kinship selection. In fact, they argue that there is no need for such a theory of inclusive fitness, since the evolution of eusociality can be explained less obfuscatingly in terms of normal selection theory itself, according to the rules we've just explained. And Hamilton's particular mathematical account of it, they say, is bogus and misleading. It's not that they're saying there isn't kin selection. In fact, kin selection is the major context in which cooperation occurs. I mean, the majority of animal forms of cooperation are between kin-related elements. Not all, interestingly. So they're not saying that isn't the case, but they're saying that the particular mathematical formula that Hamilton used to explain this is bogus. And you would think people's lives depended on this, because empirical biologists, who on the whole, probably some of you here, are quite suspicious of this mathematicalization of their realm and see it as a kind of physics envy, nonetheless like to justify some of their conclusions by, it's quite a trope, putting in at the end of one of their articles about the empirical observation of meerkats in the Kalahari, a little appeal to the Hamilton rule in maths to make it look rather neat. And so 130 so people signed an irate letter against this article. And it turns out they didn't really understand the maths themselves, but what they were worried about was that it seemed to threaten their whole livelihood, as it were. I'm not going to go into this in huge detail, but the key difficulty resides in the artificial way in which Hamilton chose to mathematicalize fitness in relation to blood relatives. He himself put it this way, I quote, "Inclusive fitness may be envisaged as the personal fitness which an individual actively expresses in its production of adult offspring as it becomes after it has first been stripped and then aggregated in a certain way." What are we talking about? It is stripped of all components that can be considered as due to the individual's social environment. Well, that's odd to do for start. Leaving the fitness which he would express if not exposed to any harms and benefits of that environment. This quantity is then augmented by certain fractions of the quantities of harm and benefit which the individual himself causes to the fitness of his neighbours. The fractions in question are simply the coefficients of relationships appropriate to the neighbours whom he affects. Unit for clonal individuals, 1/2 for siblings, 1/4 for half-siblings, 1/8 for cousins, and finally 0 for all neighbours whose relationship can be considered negligibly small. Recall the original formula for this. R, the coefficient of relationship, must be more than the cost of cooperation, C, divided by the benefit of cooperation, B. Now, the problem with this way of approaching things, says Novak and co., is that it's unnecessarily complex. I'm sure you agree with that on my brilliant exposition, and indeed misleading, because it's a way of explaining a phenomenon which can be accounted for much more elegantly by simply appealing to the usual way in which fitness is assessed in social groups by game theoretical analysis. Novak does admit, in his most recent article in the Journal of Theoretical Biology, 2012, that in some cases it may be possible to do this stripping and adding to computation in some meaningful way. But, he adds, the problem is that most evolutionary processes do not grant such additivity. I'd like to refer you here, just in closing at the end of this exposition, to a really clever article by a man who, alas, has now been exposed as having made up some quotations in another article about Bob Dylan, of all people. You've probably heard of him, Jonah Lehrer. He starred as really a fantastic young popular science exponent in the New Yorker. And one of his last articles before he got sacked, it was a Bob Dylan thing, is one which I highly commend to you, from March the 5th of this year. He interviewed both Novak and Wilson. He points out that it's so ironic that Wilson was the man who first made Bill Hamilton's inclusive fitness theory really popular, because he was interested in explaining how it might be utilised to show how his ants and bees behaved as they did. And everybody sort of went like lemmings along with E.O. Wilson's example here. But he changed his mind. He began to think that it was bogus mathematically as well as empirically misleading. And as Jonah Lehrer shows in that article, there's more at stake here than simply whether the maths works. Because what's at stake underlyingly is whether the obsessive ideological interest in selfishness as the governing motif of all evolution really stands up to scrutiny. And you probably remember that Dawkins added a special extra chapter in the second edition of the Selfish Gene to explain the prisoner's dilemma, to explain cooperation, and then at the end of the chapter used a highly misleading and sort of spine-chilling account of blood-sucking bats, because he wanted to make it sound as horrible as possible, and ended, of course, by saying that all of this cooperation across the evolutionary spectrum is simply a matter of making sure that your genes get into the next generation. It can be simply seen as a higher form of selfishness, or perhaps not even a higher form. And this is just the beginning of the cracking of that ideology at the level of the mathematical discussion, it seems to me. And of course it affects your observational and empirical work, because if you assume at the outset that there will be no cooperation by and large unless it's genetically related, you may not set up experiments and notice that the bird that's looking after that baby bird is no longer the mother, because the mother's been killed by a kestrel or something. And that in itself is proving very, very interesting in the sexual selection area of discussion. So I'm going to leave our introductory spiel there, because I really want to come on now in closing. I'm going to sit down and go into a new mode. I'll just take you onto another screen here. And I'm just going to talk for another 5 minutes, if I may, extremely briefly and hand-wavingly, about what I make of all this in the rest of the Gifford Lectures. Is that all right? I think the most fascinating thing here is that when you come out of trying to understand what the implications of these discoveries might be, you are immediately up against some not only semantic but also philosophical difficulties. As I put here, sort of close to the bottom of your sheet, problems for discussion. It's not quite clear, and you'll see that from what I've said, how much of this science comes front-loaded with narratives of meaning. How much of this science comes on the assumption that we can continue with the overriding ideology of selfishness, which has been so regnant in the latter part of the 20th century. It clearly is a certain threat to that, because it's talking about these countervailing factors which have to be present, even for defection, even for selfishness to flourish itself. Because if they're not there, there would be no flourishing communities of evolutionary life. But how to assess the final meaning of this is highly problematic. And I've listed at least 5 problems here. There is an inexorably hermeneutical and philosophical set of questions that this material leaves for us, how to interpret it. There's also, I hope some of you have been balking at this, there's a real problem about how much of reality this maths catches. These mathematicians think it catches everything because they're that kind of mathematician. But it clearly doesn't, because it is only a stochastic set of regularities, very significant, which of course have only a certain explanatory force. And so there's quite a lot that has not yet been fed into the mathematical pot here, and even if it were, it's not clear how far the mathematics could go in explaining it. For instance, how do different species interrelate with one another, which they're constantly doing in the wild. We've got to find mathematics that could explain those interactions, and how much does the environment affect what is happening. Crucial too, as I underscored earlier, what is the difference between pre-human and human manifestations of these behaviours? When you feed human intentionality and cognitive power into this, we have this hyper ability to work out on the basis of this information what we want to do with this. And this is fascinating. I remember saying to Ed Wilson in one of his lectures, because he was talking about the imminent loss of almost all amphibians in hotspots in our ecology in the next 50 years, unless we do something very radical, which, by the way, wouldn't cost very much. I said, are you saying that actually the human race has now got to reach a new level of cooperation that it has never achieved before? It's got to cooperate across national boundaries, across political differences, if it's going to, as it were, effect a way of maintaining our ecology for the future for humans. And that's clearly a very high and new level of cooperation, but there are many other different layers of cooperation. And problematic here too is the very idea of cultural evolution, which many people, Dennis Alexander doesn't really believe in cultural evolution. He doesn't think it is evolutionary. He thinks it's something that just supervenes over genetic material, which is entirely human and can't be placed in evolutionary spot. But this whole mathematics assumes that the pre-human is a praeparatio, as it were, for the human, that it genetically prepares us for capacities and behaviours which we can then refine and extend in ways that haven't been already. And finally, note that there's nothing about this material that is in itself ethical or unethical. Martin himself often speaks as if cooperation is nice and defection is nasty. but you can cooperate, we can cooperate for all kinds of unethical ends. I'm sure Nazis were quite good at cooperating on certain fronts. We can cooperate as hunter-gatherers to kill off our enemies. Or we can cooperate for very good ends. So the whole question that only comes up in the human realm is what meta-ethic and what ethic you're going to choose, as it were, to align with our thinking about this. Okay, let me just end then with what I do with this in the remainder of the lectures. And I'd be delighted if you had some time to look at these online, and if you feel moved, let me know what you think. Because I make two very bold moves, and they come together at the end. The first bold move is an ethical one. In lecture 3, I go back to the project of what's sometimes called evolutionary ethics. And I ask what these evidences about cooperation and altruism tell us about what choices we might want to make in the meta-ethical realm. By meta-ethical, I mean the realm in which we make choices about what counts as good. And one of the embarrassing and difficult things here is that almost all economic game theorists who use this calculus are very narrow-minded, short-term utilitarians. And they've given the whole calculus a very bad name for that. They're interested in quick payoffs. And you could say that it's not a coincidence that this game theory came into popularity at the end of the 20th century, in a period of boom and bust in the bags, at a time when Dawkins was himself announcing the priority of selfishness. Now that we have, as it were, a bit more of a perspective on that, what ethical conclusions should we draw from this phenomenon across the spectrum? And I argue, actually, that these materials drive me back, at any rate, to reconsider the idea of natural law and of virtue ethics as it were, founded and grounded in evolutionary developments, and propelling us towards forms of cooperative good, which we can only theorize as good once we are human, if you like. And yet the genetic capacity for selflessness is already given in our inheritance. And this makes, I think this gives a new flavour to Aristotelian and Thomist ethics, which is extremely exciting and interesting. It causes us to ask very unfashionable questions of biology, such as, what is this for? Which biologists don't want to ask because they've had that kind of Aristotelian drained out of them. But you must admit that that evidence that I've just shown you does make you ask that question. And so I make a new pitch, following some excellent people, including Alistair McIntyre and others, for a re-thought out evolutionary ethics along the lines of neo-Aristotelianism or Thomism. And then my second line is to reconsider the possible value of a re-thought out natural theology, working on from here. But I'm extremely careful to redefine natural theology in a way that doesn't smack of William Paley's natural theology, which of course so influenced Darwin. Darwin loved Paley in his youth, and then, as it were, got over him as he came to see that there wasn't any obvious theological teleology running through the whole of the evolutionary spectrum, even though theological language is still hanging around his every word at the beginning and end of his texts. But what I want to consider here is that when we start to ask the question, what is this for? What is cooperation for? And when we add to that the insights of Maynard Smith that the various levels of the development of the spectrum in evolution of life cannot happen without these moments of transformational intensity of cooperation. This suggests to me the possibility of working up what I call a new ethico-teleological argument for existence. That out of the whole spectrum of evolutionary life emerges a sense of goal towards altruistic behaviours, which in the human realm finally become capable of transcending even the kind of altruism that is good for your own kind. It's only in the human realm that we find people sacrificing their lives, sometimes like the monks of Tiberine, for instance, for the sake of the wider community, and even for people who are not their own genetically, and not even their own religiously. And I used in the Gifford Lectures a showing of the wonderful film of Gods and Men, which I'm sure some of you have seen, to sort of focus that issue. How can it be, evolutionarily considered, that people could behave like this? How can it be? Is this just sheer madness? Or is it perhaps the emergence of what I call supernormal ethical behavior, which is ecstatic, which is inexplicable in terms purely of the mathematical cognition, but is the human evolutionary sphere extending itself in response to divine grace, even though based on this preparation that comes right out of the evolutionary spectrum from the bacterial on upwards. So my final pitch is that if this argument might be made to work, and clearly I'm only giving you the sketch, it's got to be done in a way that is, as I call it, unimpaled. It's not going to be the kind of argument that you can get any scientist to sign on to simply on the basis of the evidences. Because, quite apart from anything else, there is no longer, and this is at the bottom of your handout, there's no longer the possibility, as Paley assumed and Darwin assumed, of a kind of flat foundation of all human knowledge that is philosophically uncontentious. On the contrary, even when we survey the evidences of cooperation, we are forced to ask, what is the story going on here that makes this comprehensible? And that's a metaphysical question. And so if I'm going to have to discuss this with Dawkins, there's going to be some bloodletting. But I'm going to have to challenge his metaphysical presumptions, which he hides under the supposed guise of science, and say that they are in no way justified by the evidence. And then we can go on from there. So there's no flat plane. I am returning to a realist neo-Aristotelianism with a newly worked view of teleology at various levels of discussion. And I am insisting that the God with whom we seek here is not a God, as Paley assumed, who was a very large item in the universe, a bit player in the universe who set it up and then had a tea break and then, tinkered occasionally. That's a bit of a... Actually, I think Paley is very badly treated. I mustn't add to that. He's a very interesting thinker. But whatever this God is, if this God is that without which there would be nothing at all, outside and sustaining and undergirding the whole reality, then any argument to that God has got to have what I call an ecstatic dimension. I don't mean a leap of irrationality. I do mean a kind of change of gear. And it's here that my interest in the emergence of the possibility of supernormal altruism is peculiarly significant, I think. I also insist that this is not the kind of natural theology where one talks generically about God, but one talks about a God out of a tradition. That would complexify it if we had a discussion with Jews and Muslims, for instance, but I'd be very happy to involve myself in that complexification. And finally I add, and this is different from naive correlation and different from a fact-value disjunction, that fact and value are emerging all the time in this evolutionary spectrum, but that for the human fully to acknowledge where the argument goes here involves not just noetic response, but also the alignment of the will and of affectivity. And that involves change in the human as the human responds to the evidences. So this is why, on various fronts, this is a very different kind of argument for God than you might expect out of the classic modern tradition of arguments for God. I've gone on too long, but that's it. We've got 5 minutes to discuss.
That's brilliant. So we do have a few minutes. David, you have a
Yes, thank you for that. Could you just make the connection with Michael Polanyi?
Yes. Well, Polanyi's life solution and so on. in the 60s, 70s was continued to talk about, as it were, levels of evolution, levels of reality, in a metaphysical way, which at the time was just thought to be dodo-like. I think that he's due for a revival, if this kind of line of argument is...
The tacit dimension.
Yes.
Is that, yes.
Yes. Yeah. Sorry, I should begin.
Yes, I think you were next, and then the lady in the fourth row.
Earlier in your talk, you were showing us a set of slides where you suggested that long-term defectors were bad news. But I was thinking,
Well, they're bad news to themselves.
not the group.
Well, and for the group, yeah. And they're bad news for everybody, really,
Well, I was thinking,
if we're talking anthropomorphically.
but I was going to suggest to you, perhaps if you looked as a population survival, that you could characterise them as imitators and learners. So one generation teaches the next
That's
one.
right.
This is the way we hunt or make a stone tool. And that's fine while the environment stays the same. But if it changes, and you want people who aren't going to cooperate, you want people who are going to be innovative, you might see those as defectors, and in those circumstances, but they would actually be beneficial.
Right, okay. Well, it all depends what group you're looking at, and then what they're responding to. And that, by the way, that's one of the things that I mentioned, that I think once you have to factor in changing environmental factors, then the maths needs to become a bit more complicated. And at the moment, it's highly abstract. So I agree with you. You're dealing with, in the human realm, with sort of traditions of behaviour, which may indeed have to be modified in the light of new circumstances. But the claim of the maths is that whatever the new circumstances and whatever the groups, the same calculus will apply, viz. If you get too many defectors, that will kill off the project. Do you see what I mean?
Oh yes, but I was thinking more about work by Boyd and Richardson.
Yes, yes, yeah.
Kamine, I can remember these two chaps' names. I think it's Kamine.
That's right, yes. Yeah.
Um,
Now they assume a rather, I mean, they do tend to assume the sort of genetic reductionism undergirding the whole story, do they not? I seem to remember. And of course one of the things I'm questioning is whether that story really is sufficient, especially in the human realm. Because I see human intentionality supervening over that in really creative and important ways. So that's where an ideological difference really affects how you adjudicate between the materials, I think.
Fascinating, thank you. Yes.
First of all, thank you so much for absolutely brilliant talk. You said that cooperation might be the magic ingredient in moving from one significant population space to another one. And that got me in mind of the notion of personal spiritual growth, which requires cooperation with the indwelling Holy Spirit or whatever. I was thinking of someone like Evagrius, who writes that you could only get to even the first stage of contemplation after really mega hard work in cooperation with the Holy Spirit. And I just wondered if that had any parallel.
Well, to me it obviously strikes valence, but I'm also a great fan of Evagrius and was rereading on prayer this very week actually. But be a little bit careful here, because this is one of these cases where you've had a semantic slide. So if you define cooperation as a behaviour in which a loss is taken for the sake of another's gain, it's a little bit unclear how you then apply that to the divine vis-a-vis the human. However, that's not to say you couldn't do it theologically. You might want to say, yes, if this story is written into the whole spectrum of evolution, then it follows that the individual in coming into relationship and union with Christ, the great manifester of transforming cooperation, has to, as it were, give way to the Holy Spirit. And actually this is where the argument goes in the lectures, because I do take it in a Trinitarian direction at the end, not in a naively correlationist way. So that's one step further, where you're bringing the divine into the equation in relationship with the transformative ongoing process. But it would apply to the monks. I mean, when the monks make their decision, are we going to stay here? We're going to put our lives on the line alongside these Muslims? The answer, yes, it is for the sake of a higher goal, which is union with Christ, through the Spirit.
Thank you. Yeah, Jim.
Again, thank you. But I am curious as to who you would like the audience for this talk to be. I mean, you've already said, I mean, this the audience for the argument, not just the talk.
Yeah.
You've said it probably won't work with Dawkins unless you're able to get him to be.
I thought you'd be very charming indeed.
Unless
Yeah.
you get him capable of being that.
We did have a showdown about memes
I see.
in public. Yeah.
But is the intended audience scientists who you hope might become more open to a religious view, or religious people who might find that their religion does make sense in a scientific world? Knows how much religious commitment does one need to follow your argument out to its conclusion?
That's a brilliant question. I had it in my mind, playing in my mind the entire time I was writing these. So the answer is I'm primarily interested in the kind of seeker who isn't a Christian. And I'm delighted to tell you that I had a very large audience in Aberdeen, and most of them were younger people who were scientists and not Christians. And they were really, really intrigued, which was great. So this is apologetics. I don't mind. It's apologetics. But secondarily, I'm interested in Christians who've been battened down by this Dawkins ideology and want some part of their elbow, and also want to think in a non-naively correlationist way. I want them to stop thinking, oh, it's just my interpretation and science rolls on its way. I want them to get into the fray about the metaphysical presumptions being made by secular science and show them how to argue about it.
Well, thank you. Now, that does bring us to 2 o'clock. I'm sure we could go on a lot longer. But thank you very much.
Thank you. It's been
That was
delightful.
great.